Momentum. Newton's first law states that objects remain in motion with a constant velocity unless acted upon by a force. In our experience, when two objects of different masses travel with the same speed, the one with the more mass is harder to stop. Then, when objects of equal masses travel with different speeds, the faster one is harder to stop. Momentum, which is abbreviated P, is defined to account for these observations. Momentum is equal to mass times velocity, or mv. The momentum of a single object is the product of its mass and its velocity. Momentum, like force, acceleration, and velocity, is a vector. So it's written with a little arrow over it. So you have the arrow over momentum, which shows it's a vector. The arrow over velocity shows it's a vector. And no arrow over mass. That's a scalar. The unit, therefore, is the product of the units in the formula. So we have kilograms from the mass and meters per second from the velocity. So the unit of momentum is kilogram meters per second. And no, there's no other name for it. Let's work a problem. What is the momentum of a 3,000 kilogram truck traveling at 25 meters per second? We write our givens, the mass and the velocity. The momentum equation is just m times v. Plug in 3,000 kilograms for the mass, 15 meters per second for the velocity, and we get 45,000 kilogram meters per second. A 1,500 kilogram ferry boat has a momentum of 30,000 kilogram meters per second. What is the velocity of the ferry boat? We have our givens up here, and we have our momentum equation. But we need to find the velocity. So we need to solve that equation for v, and we do that by dividing both sides by m. And now we have momentum over mass. Substitute in our mass and our momentum, and we have 30,000 kilogram meters per second divided by 1,500 kilograms. Kilograms will cancel out, and you're left with 20 meters per second. A car travels at a constant velocity of 24 meters per second and has a momentum of 28,800 kilogram meters per second. What is the mass of the car? We start with our momentum equation, and since we're looking for mass, we have to isolate that variable. So we'll divide both sides of the equation by v, and then switch it around so mass is on the left side. So mass is momentum over velocity. Substitute in the momentum and the velocity. Do the division, and we get 1,200 kilograms. If a system contains more than one object, the total momentum is the vector sum of the momenta of those objects. So the momentum of the system is equal to the sum of each individual momentum. So let's say in this case we have three of them, P1 plus P2 plus P3. It would be M1 V1, M2 V2 plus M3 V3. And again, these are vectors, so we have to worry about the direction. And then this means you can add any amount of momenta to your problem and solve it for that also. And here's how we figure out how to use the vector addition. We're only going to work in one dimension, so it's either going to be plus or minus for the sign of your momenta. So the first thing you do is choose a direction considered to be positive. Normally, you consider going to the right as positive and going to the left as negative. So this person would have a positive momentum, this person would have a negative. So you assign positive values to momenta in the positive direction, assign negative values to momenta in the opposite direction, and then add them all together to get your total momentum algebraically, where the negative sign counts. So let's work an example with the system of objects. We have two of them. M1 with a mass of 6 kilograms and a velocity of 13 meters per second towards the east, and M2 with a mass of 14 kilograms, 7 meters per second towards the west. We need to make one more statement. We're talking about east and west here, not positive and negative. So what we're going to do is choose the east direction as positive, which means the west direction will be negative. So here's our west direction, -7. Here's the east, +13. So we're only adding two momenta, P1 plus P2. So that's m1v1 plus m2v2. And now we plug in our numbers. So here's the first one. This is the object moving east. This one is the one moving west, and notice the negative sign here. Then you add them algebraically, and you get minus 20 kilogram meters per second. That tells us that the total momentum of the system is 20 kilogram meter per second to the west, which is what the negative means.